you can't unit test Unity projects. I've heard this so many times and I get it. Unity feels different. Everything's visual, everything's coupled, and everything runs in the editor. But here's the thing. Companies shipping games that run for years, be it AAA studios, massive mobile game companies, or indie teams with live service games, they're all test their code. Well, most anyway. If you're serious about your game's long-term success, if you want to refactor without fear, or if you want to ship updates without breaking everything, you need tests. Today, I'll show you the basics, and in the next video, we'll implement it in the 2D shooter I've created in the previous video. Let's start with the scenario every Unity developer knows. You notice that every time you open the leaderboard in your game, there's a big frame drop. It was fine during development, but now with many players it lags badly. A quick glance at the profiler shows that the problem is your custom scroll view. It's consuming a lot of CPU and slowing the game whenever it's open. After a short investigation, you decide to implement a simple cache to prevent redundant work. Everything compiles, the leaderboard opens faster, and the overall performance is improved significantly. But then, this happens. A small bug in cache system caused items to be duplicated. If a bug like this hits production, you risk game currency inflation. Players could sell items they've essentially created out of thin air. Too bad. After prototyping, the game never evolved into a server authoritative setup. Without tests, you're playing whack-a-mole with bugs. A simple test checking that dragging an item to a slot reduces inventory count would have saved you the trouble. Unit tests give you confidence to refactor without breaking everything, a sort of living documentation that actually runs and verifies itself, and more peace of mind when deploying updates. And most importantly, you stop being afraid of your own codebase. Before we dive into Unity's framework, let's clarify what unit means in unit testing. A unit is the smallest testable piece of your code, usually a single method or function. The key is isolation. You're testing one specific thing, not the entire system. Think of it like testing a single gear in a complex machine. You want to know if that gear turns properly, not if the entire machine works. Unity ships with a testing framework built in. It's based on NUnit, a battle-tested framework from the .NET world. No extra packages, no complex setup, it's just there, ready to use. And it comes in two flavors. Edit mode tests run without entering play mode. These are for testing pure logic. Damage calculations, inventory management, state machines, anything that doesn't need Unity's runtime. Play mode tests run inside Unity's play mode. They have access to everything. Game objects, physics, coroutines, animations. In an ideal world with proper inversion of control, you'd use play mode tests mainly for integration testing. But I get it. Most Unity projects weren't built with testing in mind. Your code is probably tightly coupled to MonoBehaviours. And that's fine. Play mode tests can help you test those systems. The important thing is to start testing, not to have perfect architecture from day one. Every well-structured test follows the same three-step pattern. Arrange, set up your test data and conditions. Act, execute the code you're testing. And assert, verify the result matches your expectations. Let me show you what this looks like. Let's test something real, a damage calculation system. Almost every game has one, and they're always more complex than they seem. Armor reduction, critical hits, elemental resistances. This is exactly the kind of logic that benefits from tests. Notice how clean this is? No MonoBehaviours, no game objects, just pure logic. And here's the beautiful part. When someone changes the damage formula 6 months from now, this test will immediately tell them if they broke something. But my game is all MonoBehaviours. I hear you. And that's where play mode tests come in. The Unity test attribute is your gateway to testing Unity components. You can use coroutines with yield returns, or in newer Unity versions, async await with tasks. And don't forget that cleanup. Always destroy game objects you created in tests. Otherwise, you'll have ghost objects hunting your next tests. This is testing at the MonoBehaviour level. But remember, the more you can extract into pure classes, the easier testing becomes. Let's say you have a weapon system that deals damage based on distance to target. Closer enemies take more damage. Sounds simple. But to calculate this, your weapon needs the enemy position, player position, and maybe some physics raycast for line of sight. Testing all of this together is a nightmare. So instead, we mock the parts we don't care about. Here, we're testing damage fall-off. A shotgun that deals 100 damage at point blank, but only 10 damage at max range. Instead of setting up actual game objects with transforms and positions, we mock the distance calculation. Now we can test dozens of distance scenarios in milliseconds. There are more sophisticated ways to handle mocking. Frameworks like NSubstitute or MOQ, and we'll cover those in future videos. But even simple manual mocks like this can take you far. Let me save you from the mistakes I've made. Don't test Unity's code. Transform.position works. Unity tested it, you don't need to. Don't ignore flaky tests. If a test sometimes fails, fix it or delete it. Unreliable tests are worse than no tests. And don't change tests just to make them pass. This is crucial. When a test fails, it's telling you something is wrong with your code, not the test. Unless the requirement actually changed. Then update the test first, watch it fail, then fix the code. Testing in Unity isn't just possible. It's essential for any serious and long-running project. Start small. Pick one system in your game and write a test for it today. Tomorrow, write another. Before you know it, you'll have a safety net that catches bugs before your players do. The question isn't whether you can afford to write tests, it's whether you can afford not to. If you liked this video, you'll probably enjoy my other ones as well. Don't forget to hit that like and subscribe buttons so you won't miss new content. Keep on creating, and I'll see you in the next one.